We are starting with session number 2 of continuity and differentiability. So let us go to exercise 7A. Okay, question number 14, right? So the function is written in this manner. F of x is equal to 2x minus 1. X is less than 2. Okay, f of x is equal to a. X is equal to 2. F of x is equal to x plus 1 when x is greater than 2. And it is given f of x is continuous at x equal to 2. Okay, so right hand side limit. Okay, what I'll do is, since it is given it is continuous, I'll equate all three. RHL equal to LHL, RHL equal to LHL equal to f of x equal to 2. This three I will equate. Now right hand side limit x approaching 2 plus x is greater than 2. So we have this function x plus 1. Let x is equal to 1, 2 plus h. As x is approaching 2, h will approach 0. Limit h approach 0, x is 2 plus h plus 1, 2 plus 0 plus 1 is equal to 3. Okay. Now see guys, we got by RHL this is equal to 3. Okay. And f of x equal to 2 is a, and we need to find out the value of a. So directly we can say a is equal to 3. No need to calculate LHL. Even if you are calculating LHL, this will be 3 only. Okay, so a is equal to 3 in this case. No need to solve LHL in this way. Okay, let's go to question number 15. 1, 5. Find the relation between a and b so that f of x is continuous at x is equal to 3. So f of x is equal to ax plus 1, x is less than or equal to 3, f of x is equal to bx plus 3, x is greater than 3. Okay, f of x is continuous at x equal to 3. So RHL equal to LHL equal to f of x equal to 3. Equation number 1. Now first I will start with RHL. Limit x approaching 3 plus. 3 plus means 3, x is greater than 3. So for x greater than 3, the function is 3x plus 3. Okay. So let x is equal to 3 plus h. As x approaches 3, h will approach 0. So limit h approaches 0, b into 3 plus h plus 3. There is no denominator, put the value of h as 0. Okay. So 3b plus 3. So by this we are not getting something in terms of a and b. So I'll take LHL now. Okay. Limit x approaching 3 minus. 3 minus is x lesser than 3. For x lesser than 3, the function is ax plus 1. Okay. Let x is equal to 3 minus h. As x approaches 3, h will approach 0. So limit h approaching towards 0. Okay. A into 3 minus h plus 1. A into 3 minus 0 plus 1. 3a plus 1. Okay. So we got LHL, we got RHL. So LHL is 2b plus 3. Sorry, RHL is 2b plus 3 and LHL is 2a plus 1. Okay. If you want to solve f of x equal to 3, you can do that. It's the first function itself, ax plus 1. In that, you can put the value of x as 3. Okay. So same, this also will be 2a plus 1 if you want to solve it. Okay, but then that is not required for this problem. So what you'll have to do is from 1 you have to equate this and this. So 2b plus 3 equal to 2a plus 1. So 2b minus 2a is equal to minus 2. So b minus a is equal to minus 1. Okay. Question number 15 this was. Let's go to question number 16. F of x is equal to lambda into 2x square minus x square minus 2x. This is for x less than or equal to 0. And f of x is equal to 4x plus 1 for x greater than 0. We need to find out the value of lambda. Okay, in the first part of the problem. So, given f of x is continuous at x equal to 0. So, RHL equal to LHL equal to f of x equal to 0. This we are not proving, it is continuous, so all three terms are equal. So, RHL limit x approaching 0 plus x greater than 0. Okay, 4x plus 1. Let x is equal to 0 plus h. As x approaches 0, h will also approach 0. So this is equal to limit h approaches 0, 4 into 0 plus h plus 1. So 4 into, there is no denominator, so that's really not a problem. So this is equal to 1. This is RHL. Now LHL, limit x approaches 0 minus x less than 0. So for less than 0, we have this function lambda into x square minus 2x. Let x is equal to 0 minus h. As x approaches 0, h will also approach 0. So limit h approaches 0, lambda into 0 minus h the whole square, 2 into 0 minus h. There is no denominator, put the value of h as 0. Okay, minus 2 into 0 minus 0. Okay, so this will be lambda into 0. Okay, we are finding out the value of lambda, so don't multiply this two. Okay, now from 1, LHL is equal to RHL. Okay, from 1, LHL is equal to RHL. So RHL is nothing but 1 and LHL is lambda into 0. So therefore lambda is equal to 1 upon 0. The 0 will go over here. Therefore lambda is not defined. Okay. Second part of the problem, we need to find out whether the function is continuous at x is equal to 1. Now 1 is not a critical point over here because the changes are happening at 0. Okay, very close to 0 and at 0. So 1 is not a critical value over here. So for x equal to 1, this is the function. For x equal to 1. Okay. Now why we are selecting this function is because x is greater than 0, so 1 is greater than 0. So there is only one function for x equal to 1. So you need to prove whether this function is continuous at x equal to 1. So here you do three things: LHL, RHL, and f of x equal to 1. Okay. The function will remain same in all the three cases. So calculate all the three values and it will turn out to be the same. Therefore, it's continuous at x equal to 1. Okay, now we have a shortcut also for this. Okay, that shortcut can be done in case of a one marker. Okay, now 4x plus 1 is a polynomial function. and polynomial function is continuous at any real value of x. So directly you can say, since 4x plus 1 is a polynomial function, so it is continuous at x equal to 1. Okay, because it will be continuous at any real value of x. Fine. Let's go to question number 17. Question number 17. F of x is equal to kx plus 1. Okay. F of x is equal to 4x plus 1. Kx plus 1 when x is less than or equal to pi, and 4x plus 1 when x is greater than pi. Okay. I think it is cos x. Sorry. Here it is cos x. Okay. So we need to find out the value of k such that f of x is continuous at x equal to pi. At x equal to pi. So RHL equal to LHL equal to x, f of x equal to pi, since it is continuous. Okay. So first I'm going to calculate RHL. RHL, limit x approaching pi plus x is greater than pi. So for greater than pi, we are having the function as cos x. Okay. Let x is equal to pi plus h. As x approaches pi, h will approach 0. So limit h approaching 0, cos of pi plus h. Now cos pi plus theta is minus cos theta, because in the third quadrant cos is negative. So this is minus cos h. Okay. Put the value of h as 0. Cos 0 is 1. So this is going to be minus 1. Okay. This was RHL. Now let us start with LHL. Limit x approaching pi minus. Pi minus means x is less than pi. X is less than pi. Okay. So x is less than pi is which particular function? It is kx plus 1. Okay. Let x is equal to pi minus h. As x approaches pi, h will approach 0. So limit h approaching 0, k into pi minus h plus 1. No denominators, so just put the value of h as 0. So k pi plus 1. Okay. So this is the value of LHL. Now from 1, LHL is equal to RHL. Okay. So RHL is nothing but minus 1, and LHL is k pi plus 1. So minus 1 is equal to k pi plus 1. Therefore, minus 2 is equal to k pi, and hence k is equal to minus 2 upon pi. Minus 2 upon pi. So that is the solution for question number 17. Okay. Exercise 7a. Fine. In that, let's solve question number 4. Okay. So f of x is equal to x raised to n, and we need to prove that it is continuous at x equal to n. So I'll start with RHL. Limit x approaches n plus x is greater than n, x raised to n. Let x equal to n plus h. Okay. So x is equal to n plus h. As x approaches n, h will approach 0. Okay. Just write this again. Okay, so x is equal to n plus h raised to n. There is no denominator, so put the value of h as 0. So this is n raised to n. Okay, now you do RHL on your own, LHL on your own. Okay, this thing will be minus, this thing will be minus, this thing will be minus, and LHL will also give you n raised to n. Now the third thing, f of x equal to n. So x raised to n, put x as n. So this is also n raised to n. So all three values are same. Therefore, the function is continuous at x raised to at x is equal to n. Now x raised to n is a polynomial function, so it has to be continuous at any real value of x. Okay, so that's the solution for the one marker. Directly you can say that it's a polynomial function, so it is continuous at x raised to n at x equal to n because n is any real value. It's a positive integer. Okay, but then if they're asking you for 2 marks, then show entire calculation of LHL RHL. Okay. Similarly, question number one, okay, of exercise 7a, f of x is equal to 2x square minus 1. So we need to discuss the continuity at x equal to 3. So directly we can say it's a polynomial function. So it can be continuous at any real value of x. So 3 is any real value, so it is continuous at 3. It's a polynomial function. But then if this is a for a 2 mark problem, then you have to solve entirely LHL, RHL and f of x equal to 3 and prove that the value is same. So this problem I leave it up to you. Fine. Okay.